Welcome to the Math Record. Today I'll be covering the ICTM State 2014 Division A Algebra 2. I'll be going through every single question and I'll also be timestamping it. Okay, number one. On the planet Skyron, there are 11 cities. Each pair of cities is connected by exactly one road. Find the number of roads on Skyron. So it's got to be a combination. So it's got to be 11, choose 2, because two cities have one pathway. So 11, choose 2. So that's 11 times 10. 11 factorial. Oh, sorry, 11 factorial over 2 factorial, 9 factorial. So that's 11 times 10 divided by 2, which is 55. And the reason it's choose and not permutate is that um, it doesn't matter which two roads it is. So let's say we have three islands, right? Uh, the island from A to B is the same as B to A, right? It's the same road. So it's a combination. Number two, if M equals PQR over P minus Q, solve the equation for Q. So MP minus MQ equals PQR. So get the P all to one side. And now we distribute our Q. So PR plus M. So we have MP over PR plus M. And that is your answer for number two. That's basically it. Isolate and move to the other side. Number three, find the order pair of positive prime integers AB where B is greater than or equal to A, for which AB times BA equals 6272. So I recommend just going to your calculator and factoring it, and uh, because doing by hand takes too long. So when you do it in your calculator, you get 27 times 72. Since B has to be greater than A, that means B is 7 and A equals 2. So your answer is 2 comma 7. Okay, number four. Find the order pair AB and A is greater than B where they're both positive and they're also integers, such that A plus BI times A minus BI equals 13. So A times A is A squared. A times negative BI and A times positive BI cancel each other out. And then negative BI times BI is just plus BI plus B squared is equal to 13. So the only one that works is going to be a 2 and a 3. And since A is greater than B, it's got to be a 3, 2, actually. And that's your answer for number 4. Because 3 squared plus 4, 3 squared plus 2 squared is 9 plus 4, which is 13. And that's the only one that works. Number 5. Find all values of x such that x equals f of x. So fx equals absolute value of 3x minus 1, absolute value. So what we could do is, for absolute value, there's always a positive, and then there's always a negative. So solving each one individually, this got to be a negative 2x equals negative 1. So x equals 1 half. Or negative 4x equals negative 1. So x equals 1/4. So your answer is 1 half and 1/4, which you usually just write with a comma. So 1 half, 1/4. Okay, number 6. The circle x squared plus y squared plus ax plus by plus c equals 0 has center 2, negative 1, and is tangent to line x equals negative 3. Find the value of c. Okay, so using vertex form, x plus 2 and plus y plus 1. Oh, sorry. X minus 2, because it's at 2, not negative 2. Plus y minus plus 1. And we need to find the radius. So since the line, drawing a general picture, it's at 2, negative 1, and it's tangent here. So our circle's like this. So we're working at a 2 to negative 3. So that's a difference of 5 in your radius. So that would be 5 squared here. So drawing a little picture for geometry always helps. It gets an idea, a visual way to think about it. So this is x squared minus 4x plus 4 plus y squared plus 2y plus 1, and then minus the 25 on the other side. So 4 plus 1 is 5, minus the 25 is minus 20. And that is your answer for number 6. Number 7. Find the number of four-digit numbers between 1,000 and 9,999 inclusive that could be formed from the digits in the set 0, 2, 3, 4, 6, 8, 9 using the following rules. No digits may be repeated, so you have to use one of each, and the digits must be increasing from left to right. Okay, so what I noticed is that if you can't use 0, because if it's increasing from left to right, that means 0 has to be right in the beginning. And if it's in the beginning, then it's not a four-digit number. It's going to be a three-digit. So you can only use 2, 3, 4, 6, 8, and 9. So out of these, you have to choose 4. So you could just use 6, because there's 6 numbers. Choose 4. So 6 factorial, 4 factorial, 2 factorial equals to 6 times 5 divided by 2, which is 15. And that's your answer for number 7. And the reason it's just choose is because if you just choose 4 random numbers, you could order it from left to right from smallest to biggest. So 2, 4, 6, and 9, right? Something like that. And that's basically it. It doesn't really matter how it works. Um, and number 8. So determine the M represents the determinant of matrix M. Solve for x given by 2x1, 1x2, and 3, 4, 0. Determinant of that equals 9. So what we do is you write the coefficient down of the first 3. And then the second one, you change it to the opposite. So if it's a negative, you make it positive. If it's positive, you make it negative. And then you do a 2 by 2 determinant using these. So for the first one is a 2, right? So you ignore the first column. So you use x240. So x times 0 is 0. 4 times 2 is 8. So this one's negative 8. And then for x1, you ignore the x and a 4, this column, the second column. Now you do 1, 3, and 2, 0. So 1 times 0 is 0. 3 times 2 is 6. Well, that's negative 6. And now we have 1. So we ignore the 2, 0, third column, and we work with the first 2. So 1 times 4 is 4. And then 3 times x is 3x, so minus 3x. And then that's equal to 9. And then you multiply each of these two and then add them together. So negative 16 plus 6x plus 4 minus 3x is equal to 9. So that will be equal to 3x minus 12. Add the 12 here, so that's 21. So x is equal to 7. And that is your answer for number 8. Okay. Oops. Okay. Number 9. Find the sum of all values of x for which 9 times 2 to the power of 2x plus 3 minus 4 to the power of 2x is equal to 512. Okay, so 9 times... Okay, so let's make this to 2 to the power of 2x first. So 2 to the power of 2x times 2 to the power of 3 is the same thing as 2 to the power of 2x plus 3. So then 2 to the power of 3 is 8, so 8 times 9 is 72. And then for 4, that's the power, same thing as 2 to the power of 2, so it's 2 to the power of 4x is equal to 512. And now you can see what we'll be doing now. So we can move everything to one side, so 2 power 4x minus 72 times 2 to the power of 2x minus 512 is equal to 0. So now it's like a quadratic because this one is twice the power of this one. So what we have, we can write is 2 to the power of 2x, parentheses, 2 to the power of 2x equals 0. So now we need to get somehow, there's a positive and negative because that's a negative. Now we need to get 72. So 512, maybe it's a 4. Nope. Maybe a 6. Nope, that doesn't even divide. 8. 8 and a, oops, sorry, that's a positive 512. Sorry about that. And this one is a 64 and an 8. Okay, so, oh, sorry, these are not positive. Negative. This is positive. Since this is positive, to make it negative, we have to have two negatives. So that's 64 and 8. To make that 72. 64 plus 8 is 72. Now to get 2 to the power of 2x equals 64. 64 is just 2 to the power of 6. So x equals 3. And 2 to the power 2x equals 8. And 8 is just 2 to the power 3. So x equals 3 over 2. So the sum of it is 3 plus 3 over 2, which is 9 over 2. And that is your answer for number 9. Number 10. The point 3, 5 is on the graph y equals f of x. Find the exact coordinates of coordinates of points that must be on the graph y equals f of x squared. So if your x is equal to 3 and your y is equal to 5, that exists. So to get 3 from x squared, that means x is equal to plus or minus square root 3. And then your y is 2 times the value of your original y, which is 5, so it's 10. So you have square root 3, 10, and negative square root 3, 10. And these are your two possible answers. Okay, just simple transformation. Okay, that's the first 10. Okay, number 11. So solve for x. So x plus 3 squared minus 26 absolute value is equal to 10. So that means x plus 3 squared minus 26 equals 10, or x plus 3 squared minus 26 equals negative 10. So that gives us that x plus 3 squared is equal to 36. So that means x plus 3 is equal to plus or minus 6. So that means x is equal to 3 or it's equal to negative 9. And from here we have x plus 3 squared equals 16. So this one, x plus 3 has to be plus or minus 4. So this x equals 1 or negative 7. So our answer is negative 9, negative 7, 1, and 3. These are all our 4 answers. Okay. Number 12. A rectangular solid box has 2 faces each of area 12, 2 faces each of area 16, and 2 faces each of area 8. Find the volume of the box. So let's kind of draw the picture. Using geometry, you want to draw a picture. So you have a box. And let's say this face and this face on top, right, are both area of 12. And let's say this area here in the back and this one in front, that's the area of 16. And the ones at the side, they're area 8. So find the exact area of the box. So value of the box, A, B, C. Those are the side lengths. So A times B equals 12. A times C equals 16. And B times C equals 8. So now you multiply all these together, that's A squared times B squared times C squared. That's 12 times 16 times 8. So to get the volume, we would just square root it. So that's A times B times C. So the square root of 12 times 16 times 8. So 16 square root is a 4. Take the 4 away from here to get a 2, which leaves a 2. Take the 2 and 2 here, that makes a 6. Take another 2. So that is 16 square root 6, because there's a 6 remaining. And that is your volume for your box. So that's number 12. Number 13. There exist two arithmetic sequences, A and B. Okay. Both have the same first and last term, P and Q respectively, and they're both positive. The sum of A and the sum of B differ by P and Q, so we need to find the sum of A and B. So if the first is, since they both have the first same and last term, initial and last term, so let's say A has A terms and B has B terms. Okay, determine how many more terms the sum of A and B differ by P and Q. So let's say B minus A. Let's say B is greater than A. So B over 2 P plus Q minus A over 2 P plus Q equals your difference, which is P plus Q, which is what they gave us. So determine how many more terms the sequence with the larger sum has than the sequence with smaller sum. Okay, so we could divide by P from Q from both sides. So you have B over 2 minus A over 2 is equal to 1. So that means B minus A equals 2. So that means if B is the amount of terms for sequence B and A equals the amount of terms for sequence A, that means B has 2 more terms than A. So the answer is 2. So 13 is 2. So it's just manipulating your equations around and interpreting it. Number 14. Given that log 4 of 3 equals A and log 4 of 5 equals C, write the value of log 2 of 7.5 in terms of A and C. Okay, so log 2 of 7.5 is the same thing as log 2 of 15 over 2. 15 divided by 2 is 7.5, right? Which you can also rewrite as log 2 of 3 plus log 2 of 5, because 3 times 5 is 15. That's just log rules. Minus log 2 of 2, right? When you divide and you subtract, multiply, you add. So using this, we see that this is log 2, but this is log 4. So what we say is log 4 of 3 equals A, using log change of base, so log 2 of 3 and log 2 of 4 is equal to A, and log 2 of 4, that's equal to 2. So that means log 2 of 3 is equal to 2A. And that's also the same thing as log 2 of 5 is equal to 2C, right? It's the same thing. It's just changing your 4 into a 2. So that basically substitutes for these. So we have 2A plus 2C, and log 2 of 2 is just 1. So 2A plus 2C minus 1. And it's basically just that simple. Number 15. 3 of 4 vertices of a parallelogram are the points 4, 2, 10, 4, and 6, 8. The fourth vertex is on the coordinate axes. Find the coordinates of the fourth vertex. So usually when I get coordinates of a parallelogram, I like to draw a graph and plot them. So 4, 2. It doesn't have to be accurate, but just be somewhat decent. So 10, 4. And then 6, 8. So around here. So since it has to be on an axis, definitely it's not going to be like this because then it's not going to be on an axis. So what it's most likely going to do is that there's going to be a point vertice right here for our parallelogram, right? So that's going to be this point that we're looking for. So now we just need to label them. So this point is 6, 8. This is 10, 4. And this one is 4, 2. So what we could do is we need to go from here to here. So to move in the x direction, we had to minus 6 from 10, and we had to minus 2 from 4. So we're going to do the same thing here. So 6 minus the 6 is 0, and 8 minus the 2 is 6. So it's definitely on the axis because one of these is 0. So your answer is 0, 6. And that's it. Just draw a picture and everything will make sense. Number 16. Find the largest integer x for which another integer n exists with nx equals n plus 12x. So usually what happens here is that if you're looking for one integer in respect to another, you always want to move those two integers in different sides. So nx minus n equals 12x. Nx minus 1 equals 12x. So n equals 12x over x minus 1. Okay, so if you think about it, the highest, now we have x on one side and n on one side. And if you think about it, the highest value for x, such that n is going to exist as another integer, would be if this value is equal to this value. And the reason is because if this value is like, let's say anything higher, right? If it's like lower, then it's actually, if it's the higher bound, it's gonna be x minus 1 to 12, so that makes sense for higher bound. But for the lower bound, for the lower bound, that's makes sense for lower bound. For the higher bound, it if it can't be higher than 12 because if it's, let's say it's like 13, that means this number has to like compensate for this bigger number, which doesn't work because let's give an example. Let's say this one is 14, right? That means x is 13. Oh, that doesn't work, right? And then we have this one. Let's say that's 15. That means this is 14, right? Which never gonna like work for this one. And the reason is because x, if this is an even, right? This makes it an odd. So this is a odd. So this is going to be an even, while this bottom part is going to become an odd. So even divided by odd is not possible. Or if this was an odd, then this is going to be an odd, right? So then odd minus an odd is even. So odd divided by even doesn't work. So the only way would be x minus 1 is equal to 12. And that's the highest value. That means x is equal to 13. And that's your biggest value for number 16. So a lot of questions, if you ever see a question like this, you can actually logic your way through what the equation actually means. Okay, number 17. Determine the sum of all natural numbers less than 115 that are not divisible by 7. So first we could find the sum of all the numbers less than 115. So there's 114 numbers from 1 to 114, right? From 1 to 114 is 114. And then we could find all the sum of the numbers that are divisible by 7, right? So that is from 7 to 114 divided by 7. The integer part is 16, so there's 16 terms. So 16 times 7 is 112. And then you subtract these two numbers, because this is the total amount, and this is the amount that's divisible by 7. So you subtract them, that's the total amount that's not divisible by 7. So that is 114 divided by 2 times 1 plus 114, and then 16 divided by 2 times 7 plus 112. Subtract both these numbers together, and you get 5603. And that's your answer for number 17. Okay. Number 18. Given the f and g are real non-constant functions such that for all x, y, these two equations exist, find all possible ordered pairs of f of 0 and g of 0. Express your answer as ordered pairs. Okay, so if this is going to be our f for f of x, and this is going to be our g of x, I mean, our function for f and function for g. So plug in our 0 here. That means our x plus y is equal to 0. So let's say x plus y is x equals 0 and y equals 0, right? That means f of 0 is equal to f of 0, g of 0, plus f of g of 0 times f of 0. So that's just 2 times f of 0 times g of 0. Okay, so that's your first function. And now we can look here. So we have f of 0 and f of 0 here. So what that basically tells us that we can subtract them from both sides. So 0 equals 2 times f of 0 times g of 0 minus f of 0. And it kind of works like a factor. So I factor out your f of 0. So we get 2 times g of 0 minus 1. So either our f of 0 is equal to 0, or g of 0, this thing is equal to 0, so that's 1 half. Right? 1 half times 2 is 1, minus the 1 is 0. So 0 and 1 half. And then we have our second equation. Let's move this up so we get a little bit more room to work with. We have g of 0. So if x is 0 and g is 0, so that's g of 0 squared minus f of 0 squared. Now, if f of 0 is 0, then this part is 0, then minus 0 is nothing. So you have g of 0 equals g 0 squared. And the only numbers that ever make this true is if g of 0 is equal to 1 or g of 0 is equal to 0. Okay, now what happened if g of 0 is 1 half? So that means g of 0 equals 1 half. So we substitute that with 1 half. And then g of 0, 1 half squared is 1/4 minus f of 0 squared. 1 half minus 1/4 is 1/4 equals negative f of 0 squared. And this is not going to work. And the reason is because this is positive, but this is negative. A quadratic is always positive. Times this negative means this is always going to be negative. But this is positive, so this doesn't make sense. So the only possible is if f of 0 equals 0, and our g of 0 equals 1, or if f of 0 is 0 and our g of 0 is 0. So these are the only two possible coordinates that work. 0, 0, 1, and 0, 0. Okay, number 19. Let d of n represent the largest odd divisor of n, where n is a positive integer. Find the number of values of n where n is less than 1000 for which d of n equals 3. So if the largest odd divisor is 3, right, which is what d of n is for a function, then basically the highest number is 3 and the other numbers is 2 to the power of n. And that's got to be equal to, what, sorry, 2 to the power of some kind of number x. And that has to be our n, right, which is less than 1000. Right, so how many values can that be? Well, x could start at 0 and go to, because it's going to be 0. If it's 0, that's going to be 3. So 3 is, the largest divisor is 3. So how many 2's that can that be? Um, well, you could just use your calculator and start testing. So 1, 2, 3, 4, 5, 6, 7, 8, and it could go up to 8. So from 0 to 8, that is a total of 9 numbers. So the answer for number 19 is 9. Number 20, find all positive integers n for which n squared plus 4 divided by n plus 5 would be a positive integer. Okay, so n plus 5. So a way to think about it is, instead of thinking about it like we have a function on top and a function on bottom, let's just make sure that on the top we have some kind of constant over like this function on the bottom, because then it's easier to understand. So what we could do is that we could just divide this by this. But if we do that, we get a linear term, right? So let's say we divide by this. So it would be n, and then it's n squared plus 5n. So on the top, we have negative 5n plus a, a 4 over n plus 5, right? And this just simplifies to this. So which is what it does, but it doesn't make it any more easier, right? Now we have this integer term, but we also have this function. Now instead of quadratic, is linear. So that doesn't help. So what can we do? Well, first, we could get rid of the that negative 5n on top that we had before. So what we could do is we have n plus 5. What linear function multiplies some kind of linear function, right? Let's call it f of n, multiplies to this, will only have a quadratic term and some kind of constant. Well, if you think about it, this is plus 5, so we want to get rid of it. We just need to have a minus 5. So what we could do, instead of having it n, we could have it n minus 5. Okay, so this would make n squared negative 5n plus 5n cancel out, right? Which is what we want. And then negative 5 times 5 is negative 25. So we have negative 25, but we need 4. So we have to add a 29 over n plus 5. Now this and this are also equivalent, but now it's much easier because now we have a constant and a linear. So this is the integer part. So find all positive integers. So we have n minus 5 plus 29 over n plus 5. So the only way for this entire thing to be an integer is if this is an integer, because this is already an integer. So for this part to be an integer, while n is an integer, we have to find anything that divides by 29 it's a divisor of 29. So n, the only way for that to happen for when n is equal to a positive is when n is equal to 24. Because 29 is either to is 29 is divisible by either 1 or 29. And this cannot be 1. N plus 5 cannot equal 1 because then n is equals to negative 4. It's not possible because it's positive. It shouldn't be negative. But 29 is possible. 29 minus 5 is 24. And 24 is your only answer for 20. And that's how you find number 20. So questions like these might seem hard and might seem like a bunch of trial and error, but what you have to do is that you have to view it in a different lens. So instead of like doing it as the same way as what you think of, you have to think about it in a different perspective and kind of like logically simplify it in a way that would be easier to solve. It might seem complicated to do, but once you start seeing things in different ways, it makes questions like these much easier to think about. So basically, that covers everything for Algebra 2. As an overview, basically, there's some things you need to think about, like 20, like 19, 18, but some that are really simple, like arithmetic sums with 17. Another logic question, 15 more geometry. And then basically you just need to understand your functions as 13 has taught us. Know your basic mathematics, like with logs, with absolute values, with volume. Understanding transformations, more functions, determinants. They occur sometimes, but not all the time. I think usually. And other stuff that are really simple like circles and exponents and like and variables basically. And that basically covers everything for the 2014 Division A Algebra 2. Thanks for watching, and I'll see you at the next math record.